So here we have a spring over here, right? And it's got a scale, and then it's going to force down, but eventually it's going to hit this spring. So what's going on here? So what does it read just before it touches the mass? Well, it's going to read a certain number of newtons. So part A is F equals mg. I'll bet you can do that. That's pretty simple. Now, but it reads 18 newtons. This is where we get trickier. It reads 18 newtons when the lower spring has compressed by 2.4 centimeters. And so that means that, think about it for a moment, from a force body diagram, we always have, it's 51 newtons, by the way. That's the answer to part A. If it's 51 newtons down, which is 5.2 times 9.8, but your net force, if you think about it, the net force on it, or it's reading 18, so 51 plus what upward force is going to cause this to be 18? So what do? You're going to take 51 minus 18, and that's going to give you the force of the spring pushing up. And then you just do F equals K delta X. So this number is your force. The delta X was given. It was compressed by 2.4 centimeters, and you can solve for K. Now, we have an issue, though, in that now how do we do this? When will it equal 0? Now, remember, when it equals 0, the force down, because of gravity, is always 51 newtons. So what's the force upwards from the spring? For it to read 0, of course, that'd be 51 newtons. So when the force is 51 newtons, so F equals K delta X, when this is 51 newtons, you can then take the K from part B, and you can solve for delta X.